The tube just fits in with a push-in fitting, and that's how much is extruding, sticking in. So if you need to replace the tube, that's how much it's designed to stick out. Just a tapped hole in there, standard metric. And there you can see the little plastic tube. So now we come to the hot end. So I'm showing you in the reverse. With the shiny side, that's the way it's printed, and like I said with the other parts, that's the bottom. But the trouble is, it's easier if you have the shiny side facing up. I thought I'll put them both together, shiny to shiny sides, they're flat. But the trouble is, when they print, you get a lip, and that diameter fits easily this side, but on that side it didn't fit. So you have to file the shiny side to make it fit. If you just have it the other way around, it will slide straight on. I thought it was designed to slide up for this flange to hit, and then this bracket, this flange here, to hit on here, and then this bracket will slide in there like a pair of fingers and clamp it up. But it's not to be. It's not designed like that at all. It's actually designed to fit in that slot. So in theory, that slot there has to be the exact thickness of that particular part. If it's 1/2 mil loose, smaller, you'll be able to push it up 1/2 mil. So that's where the design is wrong, and you should pull up against the flange face and tighten it up. Would have been better for this to pull up to that face, and this slide over the slot and screwed in from the top, which I believe is probably the way it may have been, except for this bracket. That's what throws me. So when I design my own head, my own effector, it will be a quick twist lock. But then the other problem is that they've got a recess in this top part, but the height from there to the height of there is what it's supposed to be tight. So if you mistakenly try to file that recess down, see that step, that's how much slop you're going to have. There's nothing pulling it up on the top, so do not file that step. And in fact, you get the light right sometimes, you can see right through. So if you remember when I used the plastic welding technique, what I'll do is I'll just get a strip of PLA that I supplied, get the soldering iron, melt it, then just get a flat knife or something smooth and flatten it down to build it up. That's why this wasn't finished. I wanted to show you the faults and how to fix it. We're back to basically the last bit. How loose it is? That's filing, that's a lot tighter. So that's your shape. However, and that's the grooves I was talking about. However, this is a bit of a keyhole shape, but it doesn't fit. It's about 1.5 mil, 2 mil too narrow. So you have to file the flats on the plastic there, then curve it. Then when you push it in, you should just have it to be a tight snap-in fit. Still rotates, but it's difficult to rotate. So I'll need to remove that, solder, plastic weld it up to fix it, and then reassemble it. There are some holes here, tapped holes, that you can use to perhaps make a support. That's how much is in an unbushed hole, and that's how much there is with the bush top. It slides smooth, beautiful, and I thought fantastic. But the trouble is, by the time you assemble it all, that will be sitting on an angle, that will be sitting on an angle, so you really need, I think, to screw it together and bore and put a bush. But the idea is I'll remove the end here and I'll just drill and tap on the bottom. Then where the guide is, I'll drill and tap here on the bottom. Where that comes down, I'll mount a plate with a hole in it. So then the plate will sit there with the hole, and this is the most important part down here. Doesn't move. And then that will be the guide. You could have the plate on the hot end, but you then transferring the heat to that, to that, to that. So just on here, flat plate. And if you designed your fan shroud, I spoke to you before, if you design that right and large enough, you will be able to drill a little hole in that to use that as your guide. So that's the plan. So that's the stage we're up to here. And as you can see, the effector does need some work. So once that's done and fixed, I'll get back to you. I got Simtron to send out the STL files for the carriage and the effector. These on the drawing are 40mm, and that's what they measure up roughly to be once you square them all up. But these on the STL are 38.5, so they're 1.5mm smaller, designed 1.5mm smaller than those. So I'll be pulling these off, mill them down to say 37, mill these down to 37. So there's parallel, and so there's also clearance. I asked them about the locking, the binding, and they said that's acceptable. So what you have to do with the arms is make sure they are all in. And they say that if they stay like that, you don't have any binding problems, which is true. But I'll machine mine square, then I'll see. That's the recess I was talking about. So that's it, prefix. And that's it now welded. Just cut a strip up, put it on, use the max pen, melt a bit, flatten it with your knife, melt another piece, flatten it with your knife, melt another piece, flatten it with your knife, look at the angle, see any high spots, just touch it with the max gun again, and melt it. So yeah, so that's it, and then just touch it up with a file, get any high spots off, job done, minute or two. So, plastic welding, highly recommend it. So then I'll get back to you with the next stage.